we will continue with uh, that is Sieve prime algorithm, Sieve's Eratosthenes, right? Algorithm, which we were using it for checking the number is prime or not. Okay, so we will continue with this same logic, but we will solve different kind of problems using that algorithm. Okay, let us start now. Okay, now suppose let's say that, right, write a program, write a program to print prime up to prime up to n. So this would be the question for it. Okay, now, right, so suppose if I give n is equal to 30, I need to print prime numbers up to 30, right? Right, I have to print prime numbers up to 30, or all the prime numbers which come below 30, right, or up to 30. Okay, so this is what we need to print now, right? The Sieve's algorithm, right, Sieve of Eratosthenes says that, right, so the definition of Sieve of Eratosthenes is, right, if n is not divisible by, not divisible by any prime factors, prime factors, then n is prime, then n is prime. Okay, so I hope it is audible to all of you. Okay, so then n is prime. Now we will use this algorithm, right, to generate, right, to print prime numbers up to n. Let's see how we can do that. Okay, let's see how we can do that. So first of all, right, so first step one is, right, generate numbers from 1 to n. Okay, so let us take the example as n is equal to 30. Okay, n is equal to 30. Okay, this is what we will take. So what we will do, we will write down all the numbers, right, starting from 1, right, up to 30. Okay, right, 12, 13, 14, 15, 16. Feels like I'm going to school now. Then I started counting the numbers from the beginning, right? So obviously, it's kind of school feeling when you start counting these numbers and start writing them. Okay. So once we generate all these numbers, what is the next step? Right? You need to understand the fact that the first number 1, it is not a prime, neither composite. So ignore that number. Okay. So step 2 is, right? Step 2 is start from the first prime number. Start from the first prime number. So according to definition, what does the definition says? The given n is not divisible by any prime factors. Then obviously the first number, prime number 2, is a prime number. So what we will do is, right, what we will do is we will keep, right, the number 2 and remove multiples of multiples of 2. So because multiples of 2 have got a prime factor, right, multiples of 2 have got a, right, a factor called as 2, which is a prime. So multiples of 2 cannot become a prime only. So what we will do is we will start removing multiples of 2. Remove all the multiples of 2 till 30, right? Remove all the multiples of 2 till 30. Okay. Now let's see, have I left any number? No, I have not left any number. So the next step is, right? The next step is we need to go with the next number, right? So the next number is I is equal to 3. Now, is it present in the list? Yes, it is present in the list because 3 is also prime number. So now we will repeat the same process. We will keep the number 3 and we will remove, right, multiples of 3. Multiples of 3. So start removing multiples of 3. So the first multiple of 3 we will remove is 9, then 15, then 21, right? Then 27. Okay. So what is the next number? The next number is I is equal to 4. These are the sequential number we are generating. Now when I is equal to 4, kindly observe here in the list, right? The list of numbers what we had, right? When I is equal to 4, check whether the number 4 is present in the list or not. So since the number is not present in the list because it is already removed, so what we have to do is you need to skip removing multiples of 4, right? Since already removed from the list, already removed from list. So what we have to do when I is equal to 4, skip it, which means, right, next number is 5, right? The next number is 5. So when you have 5, right, you check the number 5 is present in the list. So before you start removing multiples of any number, before you start removing multiples of any I, you need to check whether that I value is present in the list or not, right? So if it is not present in the list, then skip it. If it is present in the list, then keep that number, keep 5 and remove multiples of 5. Remove multiples of 5. So how long we can keep on doing this, right? Right? How long we can keep on doing this? So what they have told in the definition, he has mentioned the word called as factors. Now, how do we select the least common factors, right? Till I star I less than or equal to n, right? Till I star I less than or equal to n. So after 5, when I is equal to 5, 5 into 5 is 25, less than or equal to 30, condition is true. So we removed multiples of 5. When I value becomes 6, 6 into 6 is 36, less than or equal to 30, condition fails, then stop it. Stop removing the multiples. Now, after doing all this job, now you check, right? Now you check the remaining numbers, the numbers which are left out, the numbers which are remaining, they are your prime numbers. They are your prime numbers. So sorry, I did not remove multiples of 5. Let's remove that. Okay. So the remaining numbers will be your prime numbers. Are you understanding this? Are you clear on this? Okay. Sorry, I'll repeat it again. I'm sorry. Okay. So for this program, we need only one input. So read the value from the user, read the n value from the user, right? And call a function called as Sieve prime, right? Call the function as a Sieve prime, pass n as a parameter. Now, right, what is the job of this function? Sieve prime function. What it does, it generates primes up to n, and it also prints them. So obviously this function will not return anything. So return type of the function will be void. Return type of the function will be void. Since we are passing only one parameter, right, we will receive only one parameter here also, integer. Now next thing is, right, if you observe here, right, I'm sorry, okay, if you observe in this question, what is the first step? I need to generate numbers from 1 to n. Okay, if you are generating multiple numbers of same type, then we need to store them somewhere. So where would we store numbers of same data type? Obviously integers. Let's create an integer array with a size n. Okay, if I create a size array with a size n, now let's look at it pictorial representation. Let us look at it in a pictorial representation. Okay, so what I will do is I'll draw an array here. I'll draw the array here, right? I'll draw the array here. So let's visualize it. Okay, let's visualize it. Okay, so if you create an array assuming n is equal to 30, if you create an array with this size, so what will be the index of these array elements? 0 1 2 3 4 5 6 7 8 9 and so on. Okay, last index will be 29. Okay, so we got, right, 30 memories, right? We got 30 memories. Okay, we got 30 memories, but the problem is, we now, you can also observe that we already have the numbers here, 1 2 3 4 5 6 7. We already have these numbers, 1 to 29 numbers are present, but only number which is missing is 30. So what we will do is, while declaring the array, we will declare it as n plus 1, so that we will also get the number 30. So that we will also get the number 30 in our list. So what I'm trying to say is that we are using the array index, right? We are using array index, right? We are using array index as a list of number, using indexes as list of numbers. We are using, right, indexes as list of number. Now I've right, when we came across with this option, when I is equal to 4, I told you that, right, that time I had mentioned, whenever you are removing multiple of any number, first we need to check whether that number is present in the list or not. So what we will do here is, initially we will fill every element. We will fill every element. Okay, we will fill every element with some status indicator, either 0 or 1. Let us fill it as 1 in the beginning. Every element I will fill it as 1. All the array elements are initialized to 1. So what is this 1? This 1 indicates number is present. 1 indicates the number is present in the list. Now how do I remove that number from the list? I will make the element as 0. If the element is 0, then the number is removed from the list. Okay, so if the array element is 1, it is present in the list. If array element is 0, then it is removed from the list. So it is a kind of indication or a status indicator, we call it as. We call it as status indicator. Now, right, if you observe this logic, from where are we starting now? Right, we are starting from 2. So what we will do now is, first let us initialize the entire array with element 1. Let us initialize entire array with element 1. Okay, so for I is equal to 0, I less than or equal to n. Why we have to write less than or equal to? Because the size is n plus 1. Because of that, we have to write it as equal to n. Or if you don't want, you can write it as I less than n plus 1. Instead of writing plus 1, I'm going with here assignment operator. Inside this, initialize every element with 1. 1 indicates all the numbers are present in the list. If the element is 0, then the corresponding number is removed from the list. Now, as I've told you that we will start generating numbers, sequential numbers starting from 2. Why from 2? Because 2 is a first prime number. Okay. So what is the exit condition? What is the exit condition till where we should keep on doing it? Till, right, I star I less than or equal to n. So that is, you select only the factors. You select only the factors. So I plus plus. Okay. Inside this. Okay. So what does this loop is doing? This loop is generating, right, I values 2, 3, 4, 5, 6, and so on. Okay, it is generating I values 2, 3, 4, 5, 6, and so on, starting from 2. Okay, now what we will do is, right, so what we have done here, for I is equal to 2, exit condition is I star I less than or equal to n I plus plus. So we have the list now. Okay, now what I have done here in this case, so first we need to keep the number 2 and remove the multiples of 2. So since I is starting from, since I is starting from 2, since I is starting from 2, we need to start generating multiples of I. So what we need to do is start removing multiples. But before removing, I have told you that we need to check if primes of I is equal to 1. This condition indicates what? Right? It becomes true if number is present in the list. Okay, if the number is present, then only we should remove the multiples. Correct? Then only we should remove the multiples. So how do you generate the multiples now? Okay, this will generate, so j is equal to I star I, right, j less than or equal to n, j is equal to j plus I. Now this will generate multiples of, right, I, right, I'll write down here, generate multiple of I. So when I is equal to 2, right, we will generate the multiples as 2, right, sorry, j becomes 4, j becomes 4. So after 4, what is the next multiple? Next multiple is 6, next multiple is 8, next multiple is 10. Like that, you need to increment the j by I value. Okay, you need to increment the j value by I in the step of I. Now when I is equal to 3, the first multiple we have removed was 9. The first multiple we removed was 9. So instead of writing I plus I, we have to write it as I star I, because no need of removing 6. 6 is already removed by the number 2. So directly we will jump to I star I, which is 9. So 9 12, 15, and so on, right? So because when I is equal to 3, you need to increment the j value by 3. So j is getting incremented by I. So now when I is equal to 4, when I is equal to 4, what is happening? Now you check here, right? When I is equal to 4, right? We need to skip it. This condition gets failed. So what we have to do inside this for loop? Inside this for loop, you need to start removing multiples of prime, multiples of I. Multiples of I is given by which variable? J. So primes of j is equal to 0. This is what we need to do, right? So when I is equal to 2, first value j is equal to 4. So what will happen here? This value will become 0. Next, this one will become 0. Next, this will become 0. Like that, it will make all the multiples of 2 as 0. Right? Now, next time when I is equal to 2, sorry, when I is equal to 3. Now check primes of 3. Check this condition, primes of 3. Is it equal to 1? Yes, it is equal to 1. So then remove the multiples of 3. So the first number you will remove is 9. And so on till last element. You will remove all multiples of 3. Now similarly, when I value is equal to 4, right? Now you check what happened here. Primes of 4. Is it equal to 1? No. Why it is 0? Because that is already removed by multiple of 2. So once you finish the execution of this loop, till this condition is true, keep on repeating it. Once it is done, all your prime numbers are generated. This is the logic of that. So let us check the condition first. First, let us check the condition. If primes of I is equal to 1. So what does this is doing? Right? Checking number is present in list. Okay. If it is present in a list, then remove the multiples of I. So j is equal to I star I, j less than or equal to n, j is equal to j plus I. So what is this? J is generating multiples of I. J is generating multiples of I. So whenever you get a multiples of I, right, make that element as 0. Right? Make that element as 0. Once you come out of these for loops, all your prime numbers are generated. So what is the next step? Print all primes, right, whose element is 1. Whose element is 1. Okay. Whose element is 1. So which one becomes a prime there? Which one becomes a prime? Okay. Index becomes a prime number. So how do we print that? For I is equal to starting from 2, I less than or equal to n, I plus plus. Inside this, check if primes of I is equal to 1, then print f percentage d slash t double quote comma print I, because I index is our prime number. Index is our prime number because we took the index as the list of numbers, right? We took index as we are using index as list of numbers. So if the element is 1, then this one becomes a prime number. Now if this element is 1, then this one becomes a prime number. So like that, right? Wherever the element is 1, print the index of that, right? Print the index of that, right? Let's check with certain giving some number as a input. Let's give 20 and see all the prime numbers up below 20 or up to 20 are generated and printed. Let's start with one more example, right? So there is something called as one more example which comes in prime number is, right? Write a program, write a program to print, to print, right? To print, right? Super primes up to n. Okay, okay, super primes up to n. So what is the meaning of super prime, right? So let us take an example and understand it better. Okay, let us take an example and understand it better. So n is equal to, let's say, 30. Okay, n is equal to 30. So let us write down all the prime numbers which come under, right, 30. 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. So these are the prime number which come under, right, 30. So these are prime numbers. Okay. Now let's start putting an indexing for these. Start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the index numbers. Index numbers. Okay. So these are index numbers. Okay. Now if your index number, if the index number is a prime, then 3 becomes a super prime. If the index of that number is a prime, then that 3 becomes a super prime. Now you look at this index, right? 3, that is a prime. So 5 is also a super prime. Then the next number comes is 5. So 5 is a prime number. So 11 becomes a super prime, right? Then you look at 7, right? 7 is a prime number. 17 is a super prime. So do we have any other prime numbers here? No. We don't have a prime index. So these are the super primes. Super primes. These are super primes up to 30. So what is the idea? How do we solve it? Generate the primes up to n, right? Using sieve method. Okay, using sieve method. Then copy all primes up to n into another array starting from index 1. Okay, index 1, right? So let us finish these two jobs and then we will come back. Okay, first we will finish these two jobs and then we'll come back with the remaining part of the logic. Okay, so already we have written, right, a logic to generate prime numbers. Okay, now what we have to do is, right, I need to declare another array int super prime of, you can declare the same size, right, right, usually it will be n divided by 2, right, half of it, you will not have more than half. So we will allocate the size as half of that, right? If n is 30, right, the the super prime numbers will be half of that, right? It won't be more than that, right? So that is how the logic. I'll tell you how it comes into existence. We will look at that formula also. I'll provide you a link also to read that. Okay. Now what we have to do is we need to copy all the primes. Whichever primes are getting generated here, these prime numbers, we need to copy it into another array called as, right, super primes is equal to I. So instead of printing I value, we will copy all the elements, right, into another array starting from, I will initialize k is equal to 1. So I'm initializing two variables here. One is I is equal to 2 and k is equal to 1. And whenever you store a prime number, then increment k value. After storing that prime number into super primes, right, store that into, right, increment the k value. Okay, after storing. Once you are done with that, right, so are you clear till this point? So the next step is, right, print super primes. Okay, print super primes. How do we print super primes here? Right, for, right, I is equal to 2, I less than or equal to n divided by 2, I plus plus, because the size of, sorry, not I is equal to 1, I is equal to starting from 1, because that index of super prime, I'm storing the values from index 1, so that is why I'll start from 1. Then now what I will do is, right, even 1 is not a prime, 1 is not a prime, so you can directly start from 2, right? So you can start from 2. Now what we have to do is we have to check if, right, how do we check this, right, how do we check this, right, super, if 2 is a prime or not, we have to check if primes of, if primes of I is equal to 1, if primes of I is equal to 1, then print f percentage d slash t double quote comma super primes of I. Are you understanding this or should we explain? So what exactly we are trying to do here is, right, so you already have this, you have these prime numbers, right? So these prime numbers which are present in the array, we already have that. Okay, one second. Okay, we will copy that. One second now. So we have all the prime numbers here. Okay, I didn't copy the line. It's okay. Better we'll write down all that one more time. Okay. Okay. So all these prime, the values which are present in the array. Okay. See, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Okay. 30, 29, 28, 27, 26. So here this will be 1, 1. This is 1, 1, 0, 1, 0, 1, 0, 0, 0, 0, 0, 1, 0. Okay. So now what we will do is we will copy all these elements, all these prime numbers, right? We will copy all these prime numbers into another array. We will copy all these elements into another array. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Just assumed array size. Okay. Now what I'm doing is, so this 2 is a right, the element 2 is a right index value, the element is 1, so 2 becomes a prime number. So I'll write down the 2 here, 3 here, 5 here, right, and then what you call 7, then 11, 13, 17, 19, right, 23 and 29. So these are the prime numbers I have copied into another array. So this is a primes array, this is a primes array, okay, and this is super primes array, super primes array, okay. Now what I did was I took a loop I is equal to starting from 2 because 1 cannot be a prime. So starting from 2, what I will do is I will check this if primes of 2 is it equal to 1. I am checking this number 2, is it prime or not. I am checking that 2 by referring it to this table. If it is equal to 1, then obviously this 2 is a prime, right? If it is equal to 1, if that in the primes array, if this index is having a element 1, then obviously the index is right, the index is a prime number. If the index is prime number, right, if the index is prime number, then I have to print what, percentage d double quote comma super prime of 2, correct, super prime of 2. So it prints 3. Now instead of this, what I did was for loop starting I is equal to 2, I less than or equal to n divided by 2, I plus plus. I am repeating these statements. I am repeating these statements. Now instead of 2, we will have right I there, right. You will take this index and refer it to this array to decide that this index is prime or not. Are you clear, buddy? See, K will keep a track of how many prime numbers are there in the super prime array. So what I have to do is I need to traverse it only till K. I need to traverse it only till K, not entire array. Okay, let's give 30. Okay, one element which is coming as extra because I had written in a loop I less than or equal to K. It should be I less than K. Then we will get the correct answer. See, sorry, not primes up to. I think we have to change this sentence super primes up to 30. So all the super primes are generated. So basically what is happening here is, okay, this K variable, okay, this K variable, right, it is keeping a track of how many prime numbers I am copying in this array. So I need to traverse only how many primes are there, only till there. So that's why it should be I less than K. There is no point in traversing entire array, right? Let's start with another example, that is print primes between between range m and n. So we have already written a function called as is prime in the previous session. This function was checking a given number is prime or not. This was checking given number is prime or not. So first of all, let's start with that hash include stdio.h, right? So we will write that function which was done in the previous session. So int n. So we had written all the condition. If n is equal to 0 or n is equal to 1, it is not a prime. So return 0. If the number is less than or equal to 3, then the n values are 2 and 3. 2 and 3 are prime numbers. So return 1. Now check the divisibility. N mod 2 is equal to 0 or n mod 3 is equal to 0. If the number is divisible by the first two prime numbers, then it is not a prime, then return 0. Next, what we have to do is we have to generate the remaining prime numbers. We have to generate the remaining prime numbers starting from 5. But how many prime numbers we need to select? Only the prime factor. And to select the factors, we know the condition is I star I less than or equal to n. So, and I must be incremented by 6, right? So, in this loop, we will check the number is divisible by I. Also, we will check, also, we will check number is divisible by I plus 2. Means at the same time you are checking 5 and 7, 11 and 13, 17 and 19, like that. You will check the number is divisible by remaining prime numbers. If it is divisible, condition becomes true, then return 0. If all condition fails, return 1 because it is a prime number. Okay, because it is a prime number. Now, we had written this function in the previous session. We just repeated it. Now, what we need to do is we need two inputs from the user, m and n. We need the range of numbers m and n. And also, if you are having a range, we need one loop variable, loop iteration variable I, okay, to generate numbers from m to n. Now enter m and n values, scanf %d double quote comma ampersand m comma ampersand n semicolon. Once we get both the numbers, what we have to do is generate numbers from, right, m to n. So how do we generate them? Right, by writing a loop for I is equal to m, I less than or equal to n, I plus plus. Now here inside this loop, check is prime of I. If I is a prime, then print it. If I is a prime, then print that value I. That's it. This way you can generate prime numbers in the given range. We already know how to check a given number is prime or not using this function. So now you generate the numbers from m to n, right? Send each number to is prime. If it is prime, print that number. If it is not a prime, skip it. So that way you can print all the prime numbers here between a range. See here, let's give 10 and 30. Are we getting all the prime numbers between 10 and 30? Correct?